Welcome back, everybody. So this is the final in a series of 3 videos to kind of walk you through the mathematical gymnastics required to solve for certain variables using our gas law equations. And the first gas law we're going to look at today is the combined gas law. So previous to this, with Boyle's law, where the temperature is constant, with Charles' law, where the pressure is constant, and with Gay-Lussac's law, where the volume is constant, we've always had one of the 3 variables, pressure, volume, and temperature, held constant. That is, it doesn't change during the situation that we're discussing. Now, what we're looking at here is the combined gas law, which is an equation we would use when all of the variables change over time. And we can see here that what we're basically doing is we're combining all 3 gas laws. So you see, if we held the volume constant, we would have Gay-Lussac's law. If we held the pressure constant, we would have Charles' law. If we held the temperature constant, we would have Boyle's law. So the important part here is to be able to solve for a certain variable. So I'm going to kind of walk you through this process. And in a real equation, we would have actual numbers that we would be able to write out to solve these problems. And there will be another series of videos and tutorials kind of walking you through the actual math when we have actual numbers. But for now, I think it's helpful to work with the variables. So we are solving, in this case, for T1. And I'm going to go ahead and change to my trusty pink color here. And so we're solving for this variable. And again, we have a fraction, so the first thing we want to do is cross multiply. So on one side, we're going to have P1 times V1 times T2. And on the other side, we're going to have P2 times V2 times T1. And so again, T1 is what we want to solve for. We want that to be by itself on one side of the equation. And so we have to get rid of all the other variables that are on that side of the equation. And again, because we've cross-multiplied, the way we've arranged the equation now, we're multiplying all of those variables together. So in order to get them to the other side, we have to divide both sides by both P2 and V2. So we're going to go ahead and, again, divide both sides by P2 times V2. We're going to eliminate those variables, and then on the other side, we're going to end up with T1 all by itself, because we've canceled everything else out, equals P1 times V1 times T2, all over P2 times V2. And this looks a little messy, it looks a little jumbled, because we have a lot of different variables to deal with. And this is where it's going to be really important to keep your work organized, to make sure you write out beforehand what numbers represent each of these variables. So then it's just a matter of plugging these numbers in and doing the math, which I know you can all do by now. So that's the combined gas law. We'll have some fun with that soon enough. And last but not least, we have the ideal gas law. And the ideal gas law brings in a variable that we haven't yet talked about yet. N is the number of moles. Now, the mole is a unit we use to measure the amount of a substance, whether it be an element or a compound in a chemical equation. And the number of moles is something we can use in balanced equations to figure out the relationship between different substances. We're going to do a lot of that after the break. But for now, this is, and we also have, we know all the other variables here and what they stand for, but in this case, we have a constant that is labeled R. And R, we're going to be given the value for R all the time, so you don't need to memorize it, but that is going to be a constant that will never ever change. So we're going to make sure we know that later on, but for now, our primary objective is to solve for T. And again, PV equals nRT is the ideal gas law equation, a classic equation that allows us to describe the behavior of almost any gas. So we have PV equals nRT. I'm going to go ahead and rewrite that equation down here just so we have it to work with. And we want to solve for T. And again, we have a situation where we're multiplying everything on the right side of the equation. So in order to get those other two variables, n and r, on the other side, we're going to need to divide. So we need to divide both sides by n times r. We're going to cancel those out on the left. And we're going to end up with T equals the pressure times the volume over the number of moles times that constant R. And if we plug those numbers in and we do the math, then we'll be able to very easily solve for T. So that's all 6 problems on the... I hope that was helpful. I hope that helped you understand the math